Next is sinking funds. A sinking fund is a fund set up to receive periodic payments. Corporations and municipalities use sinking funds to repay bond issues or retire preferred stocks, to provide the replacement of fixed assets and for other purposes. So, if we have a payment which are equal and they are made at the regular periods, they will be looking, you can try them as same as ordinary annuity. So, we can use the same kind of method which we use to solve ordinary annuity. So, let's see an example of this to understand. A business sets up sinking fund so it will be able to pay off bonds it has issued when they mature. It deposits $12,000 at the end of each quarter in an account that earns 5.2% interest compounded quarterly. How much will be in the sinking fund after 10 years? So, let's see the important points. How much is depositing every period? 12,000. So, that is your payment. At the end of each quarter means it's quarterly payments. So, 4 payments per year for 10 years. So, if I am going to use TVM solver, then N total number of payments would be 10 times 4, because 1 year 4 payments and 10 years. Interest rate is given to be 5.2%, which is compounded quarterly. Present value in the account is nothing, so that will be 0. Then we have the payment. Payment, how much are we paying every period? That is 12,000 here. Then we have future value. We have to figure that future value out. How much will be in the sinking fund after 10 years? So, that is your future value, unknown. So, leave it at 0 right now. Then we have payment per year. How many payments are we making? Quarterly payments, meaning payment per year is 4. And remember this for all your curriculum, payment per year and compounding per year, they are the same numbers always. So, don't make a mistake, they always have to be the same number in ordinary annuity. So, we enter all this in your calculator and then go back to future value that is to be found. So, press alpha here and press enter, you will get your answer. Let's try that. So, N is 40, interest rate is 5.2, present value is 0, payment is 12,000, future value unknown, leave it 0 for a second, payment per year is 4 and compounding per year are 4. Go back to the future value, press alpha and enter. You will have this amount. That means after 10 years of those payments, how much amount will be in his account? 624,369.80 cents. That would be answer to your problem. Okay. Let's read our next example. Incentive bonus. An incentive for a valued customer to remain on the job. A company plans to offer her $100,000 bonus payable when she retires in 20 years. If the company deposits $200 a month in a sinking fund, what interest must it earn with monthly compounding in order to guarantee that fund will be worth 100,000 in 20 years? So, do you see what it's saying? It needs $100,000 after 20 years. So, they start putting the money today. How much money they are putting today? $200 a month. So, that is your payment. So, the first thing I see is payment is equal to $200. For how long? They are doing it monthly for 20 years. That means N would be 20. How many months in a year? 12. 20 times 12 total payments. At what interest rate must it earn? So, the question is to find the interest rate with monthly compounding in order to guarantee that the fund will be worth 100,000 in 20 years. Meaning your future value is 100,000, that is given, and present value is 0, right? So we don't know present value, there is nothing in the account right now. Payment per year, monthly payments 12, compounding per year, because compounding is done monthly too, that is 12. So let's add all that to our calculator. What is to be found in this case? In this case, we have to find I, the interest rate. Okay. So the procedure is same. Use your TVM solver, enter everything. So N is 20 times 12. You can write it like this too. Calculator will calculate itself. I is unknown, so I'm going to make it 0 and enter. Present value is 0. Payment is $200 every month. Future value is 100,000. Payment per year are 12 and compounding per year will also be 12. They have to be the same numbers in ordinary annuity. Now, because in this case we have to find the interest rate, I go back up to the interest rate I, press alpha and press enter. So I just want to show you this. It shows the error, right? What is, there's a glitch in the calculator. The payment and the future value, they have to be the opposite signs, because one thing you're depositing and future value is supposed to be taken out from the account, right? So they have to be the opposite sign. So let's put the future value to be negative. Now let's go back, press alpha and enter. We will have I value. So I is coming to be 6.66. Once again, in the calculator, the answer comes directly in the percentage. You do not have to convert that into the percentage. So at 6.66% compounding monthly, $200 per month in 20 years will become $100,000.